Galaxy formation and evolution is one of the most fundamental and fascinating areas of study in astrophysics. The story of how galaxies came to be, and how they have changed over billions of years, is a complex and ongoing scientific saga that involves a variety of physical processes, ranging from the smallest subatomic particles to the largest cosmic structures in the universe. In this essay, I will explore the story of galaxy formation and evolution, from the earliest moments of the universe to the present day. The early universe and the formation of structure. The story of galaxy formation begins shortly after the Big Bang, the explosive event that gave birth to the universe approximately 13.8 billion years ago. At this time, the universe was a hot, dense, and uniform plasma of particles, including quarks, leptons, and photons. However, as the universe cooled, it underwent a period of rapid expansion known as cosmic inflation, which gave rise to tiny fluctuations in the density of matter. These fluctuations, which were seeded by quantum fluctuations during inflation, were amplified by the force of gravity over time. Regions of slightly higher density attracted more matter to them, while regions of slightly lower density repelled matter. This process led to the formation of clumps of matter, known as protogalaxies, which were the seeds of the first galaxies. The earliest protogalaxies were small, irregular structures consisting of gas and dust. As these structures evolved, they became more massive and began to form stars. However, the early universe was still largely composed of hydrogen and helium, with only trace amounts of heavier elements. This made it difficult for stars to form, as the heavier elements are necessary for the formation of planets and other solid bodies. 2. The birth of galaxies. Despite the challenges, the first generation of stars eventually formed within the protogalaxies. These stars were massive and short-lived, and they produced heavy elements through nuclear fusion in their cores. When they died, they released these heavy elements into the surrounding gas and dust, enriching the interstellar medium and providing the raw materials for the formation of subsequent generations of stars. Over time, the protogalaxies merged together to form larger structures, giving rise to the first galaxies. The gravitational force of these galaxies acted on the surrounding matter, pulling in gas and dust to fuel the formation of new stars. As more and more stars formed, they began to cluster together, forming globular clusters that orbited around the center of the galaxy. The first galaxies were likely small and irregular, with a mix of young, hot stars and older, cooler ones. They were also very different from the galaxies we see today, as they lacked the large, central bulges and spiral arms that are characteristic of many modern galaxies. 3. The evolution of galaxies. Over billions of years, galaxies continued to evolve and change in response to a variety of physical processes. One of the key drivers of galaxy evolution is the interplay between the gravity of the galaxy's stars and the gas and dust that make up its interstellar medium, ISM. As stars form and die within a galaxy, they release energy and heavy elements into the ISM, which can trigger the formation of new stars or cause existing ones to change their behavior. In addition to this internal evolution, galaxies also interact with their surrounding environment. They may merge with other galaxies, or be stripped of their gas and dust by passing through regions of high density in the intergalactic medium. These processes can dramatically alter the structure and appearance of a galaxy, causing it to become more compact or to lose its spiral arms. Supermassive black holes are another important player in galaxy evolution. Nearly all large galaxies are thought to contain a central supermassive black hole, which can have a significant impact on the surrounding. The story of galaxy formation and evolution begins shortly after the Big Bang, approximately 13.8 billion years ago. In the early universe, the distribution of matter was not uniform, but rather was characterized by small fluctuations in density. These fluctuations were the result of quantum fluctuations during the inflationary period of the universe, which gave rise to tiny variations in the density of matter. Over time, the force of gravity acted on these fluctuations, causing them to clump together and form dense regions of matter known as protogalaxies. These protogalaxies eventually merged together to form larger structures, giving rise to the first galaxies. As galaxies formed, they continued to evolve over time. One of the key drivers of galaxy evolution is the interplay between the gravity of the galaxy's stars and the gas and dust that make up its interstellar medium, ISM. As stars form and die within a galaxy, they release energy and heavy elements into the ISM, which can trigger the formation of new stars or cause existing ones to change their behavior. Over billions of years, galaxies have continued to evolve through various mechanisms, including mergers with other galaxies, interactions with their surrounding environment, and the influence of supermassive black holes at their centers. These processes have led to a diverse range of galaxy types, from small, irregular dwarf galaxies to massive, elliptical galaxies containing trillions of stars. Today, astronomers continue to study the formation and evolution of galaxies through a variety of observational and theoretical approaches, with the goal of understanding how these cosmic structures have come to be and what their ultimate fate may be in the far future. The Milky Way galaxy is a barred spiral galaxy that is home to our solar system and countless other stars and celestial objects. It is named after the faint, milky band of light that is visible across the night sky, which is caused by the light of billions of stars. Structure and characteristics. The Milky Way has a diameter of approximately 100,000 light-years, and it contains hundreds of billions of stars, as well as gas, dust, and dark matter. The galaxy is organized into several distinct components, including a central bulge, a disk, and a halo. The central bulge is a dense, compact region at the center of the galaxy that contains a large concentration of stars. The disk is a flattened region that surrounds the bulge, and it is characterized by its spiral arms, which contain young, hot stars and are rich in gas and dust. The halo is a roughly spherical region that surrounds the disk and contains mostly old stars and globular clusters. In addition to these main components, the Milky Way also has a number of satellite galaxies, including the Large and Small Magellanic Clouds, which are visible in the southern hemisphere. 2. Formation and evolution. The Milky Way, like all galaxies, formed through a process of gravitational collapse and accretion of matter. It is thought that the earliest protogalaxies formed shortly after the Big Bang, and that they gradually merged together over billions of years to form larger and more complex structures. The Milky Way is thought to have formed around 13.6 billion years ago, and it has been evolving ever since. Over time, the galaxy has undergone a number of important events, including the formation of its spiral arms, the growth of its central black hole, and the accretion of gas and dust from the intergalactic medium. One of the most important drivers of galaxy evolution is the interplay between the gravity of the galaxy's stars and the gas and dust that make up its interstellar medium, ISM. As stars form and die within the Milky Way, they release energy and heavy elements into the ISM, which can trigger the formation of new stars or cause existing ones to change their behavior. In addition to this internal evolution, the Milky Way also interacts with its surrounding environment. It may merge with other galaxies, or be stripped of its gas and dust by passing through regions of high density in the intergalactic medium. These processes can dramatically alter the structure and appearance of the Milky Way, causing it to become more compact or to lose its spiral arms. 3. Observations and discoveries. Scientists have been studying the Milky Way for centuries, and there is still much to be learned about this complex and fascinating galaxy. In recent years, a number of new observations and discoveries have shed light on its structure, evolution, and the nature of its constituent objects. One of the most exciting developments in the study of the Milky Way has been the discovery of exoplanets, or planets that orbit stars outside of our solar system. The Kepler mission, which launched in 2009, has detected thousands of exoplanet candidates, many of which are located within the Milky Way. These discoveries have provided new insights into the formation and evolution of planetary systems, as well as the potential for life beyond Earth. Other recent discoveries include the detection of new types of objects within the Milky Way, such as fast radio bursts and gravitational waves. These observations have opened up new avenues of research, and are helping scientists to better understand the structure and behavior of the universe as a whole. In conclusion, the Milky Way is a complex and dynamic galaxy that has played a key role in shaping our understanding of the universe.